Welcome to HBOT Journal, a channel dedicated to understanding hyperbaric oxygen therapy through evidence, science, and experience.
If you've ever looked into hyperbaric oxygen therapy, or HBOT, one of the first things you probably noticed is the time commitment. It's a totally fair and practical question to ask, and today we're going to get into the why behind it. So, why does a session take the time it does? And really, why can't we just speed the whole thing up? Well, the answer gets right to the heart of how this therapy is designed, and it might not be what you think. You see, the time involved in an HBOT session isn't just some random number. It's not an inconvenience, it's actually a core part of its structure. And that structure is there for one single, incredibly important reason: your safety. So let's break it down. We're going to walk through the architecture of a session step by step. We'll start with the overall structure, then look at the ascent, the plateau, and the descent. After that, we'll see how these pieces form a kind of unbreakable chain, and finally, what that means for the boundaries of the whole process. Okay, first things first. We kind of have to shift our thinking a little bit, because at its core, HBOT isn't about going fast or being intense. It's all about control, predictability, and that's absolutely essential for it to be a safe and effective treatment. And this is a really important distinction to make. Just breathing oxygen from a mask, well, that's an immediate thing you can do. But hyperbaric therapy, that's a whole different ballgame. It's a regulated medical process where pressure, time, and professional supervision are all locked together. You can't just pull one piece out without affecting the entire system. All right, let's get into the first phase of any session, the ascent. This is when the pressure starts to build. And the key thing to get here is that the speed isn't set by the machine's limits, it's set by the physical limits of the human body. It's all about how we react to those changes in pressure. So, what is pressurization? It's simply the controlled, gradual increase of pressure inside the chamber. The key word there is gradual. Think of it like an airplane taking off. It's a smooth, gentle ascent, not a rocket launch. As that external pressure slowly and carefully rises, you're going to feel a sense of fullness in your ears, just like on a flight. That's totally normal. It's just your body's signal that things are changing. And because the pace is so slow, it gives you plenty of time to equalize that pressure naturally, by swallowing or yawning, which keeps everything comfortable and safe. So, this is the crucial point. The pace is intentionally slow. It's a design feature, not a bug. It's built entirely around our own biology to make sure the body can adapt safely without any stress. It really is all about putting safety first. Okay, next up, we hit the longest part of the session. It's called the plateau, or what we often refer to as time at pressure. Now, this isn't just downtime or waiting around. This is the main event. It's when the real therapeutic work happens, where the underlying physics of the whole process is put into action. If you think about the session as having a beginning, a middle, and an end, this middle section, the plateau, is anything but passive. It's very much active time. It's a period of crucial stability that allows a pretty amazing physical process to take place. And this is that process. Normally, our oxygen gets carried around almost exclusively by our red blood cells, but under sustained pressure, something really cool happens. Oxygen can dissolve directly into the blood plasma. Think of it like stirring sugar into water. This is a fundamental law of physics, and just like dissolving sugar, it doesn't happen instantly. It needs a stable, sustained environment to work effectively. So, this phase is all about creating that steady, unchanging condition. It's about stability, not intensity. This gives the body time to adjust and just lets the laws of physics do their thing. It's a delicate balance, and you just can't rush it. And of course, what goes up must come down. The final phase, the descent, is every bit as controlled and important as the ascent. Trying to rush this part is just as risky as rushing the beginning.
The return trip to normal pressure has to be symmetrical. It needs to mirror the journey up. Your body needs that same gradual, predictable pace to readjust safely. It's exactly like a diver who has to come up to the surface slowly.
Okay, so let's tie all of this together. I want you to think of the entire session not as three separate parts, but as three links in a single, unbreakable chain. You've got your first link, pressurization. Then you have the central, main link, which is the time at pressure. And then you have the final link, depressurization. Each one is structurally dependent on the others. You simply can't have one without the other two. And here is the absolute key. If you try to shrink or remove any one of those links, like if you try to shorten the time at pressure or rush the ascent, the entire structural integrity of the process just fails. The whole chain breaks. That's why following the protocol precisely is so critical. Because when it comes to hyperbaric therapy, speed and structure are just not interchangeable. You can't trade one for the other. The structure is what guarantees control and safety, and you can't have that if you're just focused on speed.
So, understanding this structure is absolutely vital, but it's just as important to understand its boundaries, what this all means, and maybe more importantly, what it doesn't mean. This helps set the right expectations for the therapy.
This carefully designed structure doesn't mean that longer is always better, or that more pressure is always more effective. This is definitely not a more is better situation. These protocols exist for a reason, because there are very real biological limits and individual needs, and you have to respect those. When you boil it all down, the entire structure we've just walked through, the reason for the time it takes, it all rests on three core principles: the physics of how gases behave, the biology of the human body, and the absolute non-negotiable requirement for safety. They're like the three legs of a stool. Take one away, and the whole thing topples over. Which brings us right back to our original question, but hopefully with a whole new perspective. Is the time an HBOT session takes an inconvenience? Or is it the very architectural framework that makes the entire process controlled, predictable, and ultimately safe? I think when you look at the physics and the biology, the answer becomes pretty clear. Look, different designs and protocols exist for different contexts, and they always require appropriate supervision. But what you have to remember is that in hyperbaric medicine, safety is never, ever an afterthought. It is the foundation that everything else is built on.
To continue learning, explore the HBOT Journal channel.